Hey, oh, there I am. Hello. Today's programming day. I'm going to be programming in Python. That is a programming language. You could program with it. I'm more or less a beginner, but we're just going to try to learn some cool stuff by doing some fun example programs. I am, in fact, an experienced C++ programmer. I'm just trying to learn a new language, and we'll just try to come up with some quick tasks to program. So that's what we're doing today. Welcome to my stream, and let's go. Right, so we got this existing program that does roll a dice, uses NumPy. So you create a message and you print it, and you print a random message from 1 to 9, non-inclusive. But today we're going to shift gears and move over to flow controls. How about that? Let's take a look at our browser here. Let's make a different script. New file. We'll just call flowcontrol.py. Just make sure it's working. Print hello world. So if I hit F5, let's just use the Python debugger. And it says, hello world. Okay, so debugger is working just fine. So we can move on to, hang on a second, just a little adjustment here. Nobody's spamming my chat yet? Guess that's a good sign. Right. Looks like I could read everything here. Okay, so we're going to talk more about if statements. As well as the while statement just introduced in the last one. Python uses a little more than we will encounter in this chapter. So we got if statements, if x is less than whatever, and then it ends at a colon. So a little different from C. C you capture it with parentheses, but you got your indentation thing going on. So if, so you could do if, and then we got else if, which is elif, elif, and then else. So I guess that's prevent an additional. Hang on a second. Let's see, I was supposed to start a couple of hours ago, but I had some audio issues. But definitely let me know if something sounds funny. Speaking of which, let me just check something. Bro. Test. There it is. Okay. Okay, where was I? So we got if and else if and else. So let's make a quick test program. X is equal to int. Oh, and then you got the input function. Let's call it name. Please tell me your name. What if I do string? Please tell me your name, and it'll tell you your name. If name name bro colon you are my bro. Let me say, whoop. Apparently, you're not supposed to do the tab thing. Why is this? Oh, see, I'm so used to C. I did a printf. All right. elif name ski print. Do you want to ski? Then we say elif name is Johnny. Print. I can go for some Johnny Walker. Need a colon here. Yep. Then you say else colon, I'm guessing. Then we say print. Don't know you. Please don't take my money. Yep. So the point is, you got something to say if you need a person, right? Let's see if this works, because I have no idea what I'm doing. We will say F5. Please tell me your name. So if I say bro, you are my bro. Yes. Let's try it again. I press, you know what? Let's add a new line right in the front, because I hate it being all cluttered up like that. F5. Whoops, that didn't quite work right. But it said, please tell me your name. I will say, ski. Do you want to ski? Yep. So far, so good. But I guess the new line here isn't working, so we'll get rid of that. So we'll run it again. Please tell me your name. I will type Johnny. Whoop. Johnny. I can go for some Johnny Walker. Yep. I agree. I agree. All right, we're going to run it one more time. I will say that my name is Agnes. I don't know who you are. Please don't take my money. Okay. Yep. I think I really threatened that person. But without further ado, let's take a look. We got for statements. The for statement in Python differs a bit from what you may be used to in C or Pascal. Rather than always iterating over an arithmetic progression of numbers like in Pascal or giving the user the ability to define both the iteration step and the halting condition, Python's for statement iterates over the items of any sequence, a list or a string, in the order that they appear in the sequence. For example, no pun intended. Okay, you got an array of words: cat, window, and defenestrate. For W in words, print W and the length of W. Okay. So len tells you the length of an array. So it tells you the number of the elements that would appear. Okay. So if we modify this, we could say for hang on a second. Let's do something in the REPL here. Because if I say, I don't remember how to do the REPL. Python, Control-Shift-P. Whoops. No. Is that not it? I don't remember. Oh, here we go. Here's the REPL. So if I start the REPL, was it like this? 1:10. No, I don't remember. How do you make an array of numbers? Well, anyways, let's go back to the example here. And then we would say words is equal to foo bar foobar. For W in words, print W, comma, len W. So if I test it, press F5. Why? Why does it look like that? Bar. I don't know you, please don't take my money. Okay, foo, bar, and foobar are 3 and 3 and 6. Well, that doesn't seem like a very good example. My name is Apple. Please tell me your name. Name. I don't know who you are, please don't take my money. Foo is 3 letters long, Apple is 5 letters long, and foobar is 6 letters long. Yep. So those are for statements. Code that modifies a collection while iterating over that same collection can be tricky to get right. Instead, it's usually more straightforward to loop over a copy of the collection to create a new collection. So you could iterate over a copy, or you could create a new collection. Sure. For user status in... Huh? Oh, because... Hang on a second. Do they give you a way to comment these things out? Bro, I don't know what I'm doing. For users. So somehow, okay, it assigns the first item to user and the second item to status. So in this example, see, this is nice. All your strings are automatically in Unicode, so you could use even Japanese characters or whatever. But then if your code looks like this, okay, so here it iterates over a copy. Here, what happens if you print? Wait a minute. Okay. User, comma, status in... users.copy. Create a new collection. Active users empty. For user status users items. If status is active, active users user is equal to status. Right. By the way, this looks like a map. So you're mapping active and inactive status by username. Let's see. let's just try running the debugger right here. So once you get to this point, let's take a look. Iterate over a copy versus create a new collection. Users.copy.items. Okay, so the copy only exists once. And so, I see. So, you create your copy. It seems kind of odd. Copy.items. Well, you have to do .items regardless. Right. So why do you have to say .items? Because it isolates the items and then it outputs two items. It's first the first item and then the second item. So let's do something a little bit similar to this, just to make sure I understand. Okay. We'll say people is equal to Johnny. Has legs. Let's see. Scooter has wheels. And Nerf guy. Has crutches. So then we can make a thing called people with legs. This is blank array, right? Then we would say for P for people. Condition in items And then we say if condition has legs, then we say people with legs is equal to of P is equal to condition. That's it. And we could also might as well print off the list of people with legs. People with legs for P condition in people with legs dot items if we would just print the people with legs. You say these print these people have legs. Put in a new line. And then here I would print P. Was there like a print format? No, I'm not going to mess with that right now. Hang on a second. We'll just print P. Wasn't there a way to put a comma separator in between there? Who else do we want to say has legs? How about Carol? Let's see if this compiles. So I'll click F5. Boop. These people have legs, Johnny and Carol. Yeah. Because Johnny has legs, Scooter has wheels, Nerfed guy has crutches, and Carol also has legs. There you go. So far, so good. What can we do next? Then you got the range function. If you need to iterate over a sequence of numbers, the built-in function range comes in handy. It generates arithmetic progressions. So if, for example, I say list range of 20. No, did I do it wrong? Wait, how does range work? What? The term range is not recognized as the name of a command line function script file or... Huh? What? Did I spell it wrong? It says range. Am I blind? It says list range of 10. Oh, I'm not in the REPL. Why am I not in the REPL? Python. Let's try it like this. So if I say list range of 10. There we go. Okay. Yep, never forget there's a difference between the REPL and your command line. So if I say five to 12, sure enough, 5, 6, 7, 8, 9, 10, 11, not including 12. That's a key. List range of 0. Now, why are there 3 parameters? 300 increment to 19s. Yeah. Does it support decimal numbers? Let's try it. List range 0, -1, -0.1. No, I guess not. No, I guess it only does integers. Right. So it's got a start and a stop and a step. Seems pretty straightforward. The advantage of the range type over regular list or tuple is that the range object will always take the same small amount of memory, no matter the size of the range it represents. Blah, blah, blah. So it's a range object. So that's why I have to call list, is because it's a range object. Check it out. So you got R is range. R of 0 to 300 increments of 20. So if I say R, it's a range object. But if I list R, then you get that whole list. Interesting. Okay. Now what's this? Oh, okay, so if I say R, if I say R of 1, it'll probably tell me 20, right? Because it's 0 and 1. Boom, 20. What if I do R of 500? Should give me an error, maybe. There you go. It's out of range. But I could say length of R, right? Is 15. What if I say the length of the exist of R also 15? Yeah, some of these lengths, it's not clear what they do for you, right? Now here you could see -1. Oh, okay, so if I say R of -1, should give me 280. There we go. Because that'll give me the last element. And if I do R of -3, it should give me 240. Because it's 1, 2, 3. Try it out. Yep. Okay, we got a text and binary sequence type method summary, string format map, f strings. Yeah, what is all this? Do I need to know this quite yet? No. So text sequence type is string. Textual data in Python is handled with str objects or strings. They're immutable, so sequences of Unicode points. String literals are written in a variety of ways. Single quotes, double quotes, triple quotes. All right, where was I? There is also no mutable string type, but string join or IO string IO can be used to efficiently construct strings from multiple fragments. For backwards compatibility with the Python 2 series, the U prefix is once again permitted on string literals. It has no effect on the meaning of string literals and cannot be combined with the R prefix. Okay. So, return a string. My wife keeps texting me about something. Anyways. String of passing a bytes object to string without the encoding or errors argument falls under the first case of returning the informal string representation. See also the B command line to Python, for example. B thingy zoot. For more information on the string class and its methods, see text sequence type and string methods section below. To output formatted strings, see the F strings in the format string syntax sections. In addition, see the text processing services. Okay. String methods. string case fold, return a case folded copy of the string. Case folded strings may be used for caseless matching. Case folding is similar to lowercase casing but more aggressive because it is intended to remove all case distinctions in a string. Huh. Do I really need to go through all this? Center. You could count, encode. What does encode do? Return a string encoded to bytes. Right. Ends with. Is it true, false? Okay, expand tabs. Returns a copy of the string where all the tab characters are replaced by one or more spaces, depending on the current column and then given tab size. Find returns the lowest index in the string where substring sub is found within the slice. Return -1 if it is not found. Okay, you lost me with the second example. Oh. So because you're at 5, it'll say 6, because 5 is right here. Okay, yeah. String.format. Okay, that's what I was looking for earlier. This performs a string formatting operation. Right. So it probably works like this. So if I say printed format of 0 looks like a 1. So then you and then monkey. See if that works. Bump, bump. You looks like a monkey. Oh. You look like a monkey. There you go. Any lurkers in the chat? Index. It's like find but raise value error when this. Okay. Right. So you got a bunch of member functions you could use on this. Is printable. La 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 la. That's a lot of stuff. Then you got formatted string literals added in version 3.6. An F string, formerly a formatted string literal, is a string literal that is prefixed with F or F. This type of string literal allows embedding arbitrary Python expressions within replacement fields, which are delimited by curly brackets. These expressions are evaluated at runtime, similarly to string format, and are converted into regular string objects. For example, Who.title? Why? Title. Okay, so it's like a different type of string format. So I mean, is it really necessary to add another way to do this? And then you got a multi-line F string. Looks like this. Single curly bracket marks a replacement field that may contain any Python expression. So to include a literal or whatever, use a double bracket. Functions can also be used in format specifiers. What am I looking at? Is that a square root character? Square root of 2 colon. Well, you format it as a 0.5 float. 1, 2, 3, 4, 5. Kind of reminds me. Any non-string is converted using string by default. From fractions import fraction. So fraction 1, 3 is 1/3. Right, so you could do fractions. Cool. To use explicit conversion, use the exclamation mark operator followed by any of the following formats: ASCII, repr, and string. Right, so once the output has been evaluated, it can be formatted using a format specifier following a colon. After the expression has been evaluated and possibly converted to string, the format method of the result is called with the format specifier of the empty string if no format specifier is given. The formatted result is then used as the final value for the replacement field, for example, from fractions import fraction. Am I understanding this correctly? You have 10 characters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Format specifier following a colon. Yep. After the expression has been evaluated and possibly converted to a string underscore format underscore method of the result is called with the format specifier or the empty string if no format specifier is given. For the following format, the result is then used as the final value for the replacement field, for example. Yeah. The formatting operations described here exhibit a variety of quirks that lead to a number of common errors, such as failing to display tuples in dictionaries correctly, using formatted string literals. The str format interface or string template may avoid these errors. Right, so it's called the percentage operator. Modulo. I could go from Modelo. This is also known as the string formatting range interpolation operator. Given format percent values, where format is a string, percent conversion specifications in format are replaced with 0 or more elements of values. The effect is similar to using sprintf function in the C language, for example, print. String has D quote types. This feels very familiar. So Python has 2 quote types. Yep. So I could do it like this. Print. I have fingers and I could use a S. So I have 10 fingers and I could use a salad. Did I goof something? Oh, I know what I did. And then I'm supposed to do the Modulo. Modelo. We'll just call it Modelo. I put in the Modelo. Oop. I have 10 fingers and I could use a salad. Yep. Kind of goofy. Kind of goofy. I'm just going to skip this section. All right. Binary sequence types. You got bytes, byte array, and memory view. So I do a lot of low-level stuff in my line of work, so that's the kind of stuff I like. Bytes. Core built-in types for manipulating binary data are bytes and byte array. They are supported by memory view, which uses the buffer protocol to access the memory of other binary objects without needing to make a copy. The array module supports efficient storage of basic data types like 32-bit integers and double precision floating values. Byte objects are immutable sequences of single bytes. They really like this immutability thing, don't they? Since many major binary protocols are based on the ASCII text encoding, bytes objects offer several methods that are only valid when working with ASCII compatible data and are closely related to string objects in a variety of other ways. Class bytes. Skip that. Then you got hex stuff. Since byte objects are sequences of integers, I can do a tuple for byte object B. B0 will be an integer, will be 0:1 will be a bytes object of length 1. This contrasts with the text strings, where both indexing and slicing will produce a string of length 1. Okay. I could use some coffee. Hang on a second. Let's see. Coffee break. Be right back. Just a minute. Yo, I am back. Any lurkers in the chat? This is my cold brew coffee from Costco Kirkland Signature. Hoping to get a little burst of caffeine here because I'm yawning reading this documentation here. Hoping to run a couple more fun little programs here and there. Let's skip this section. I'm bored to tears. Byte and byte array operations. Both bytes and byte array objects support the common sequence operations they interpolate. Okay, I don't care too much about this. Blah 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 blah. Can always look this up, right? Printf style of bytes formatting. Oh my gosh, alright. Memory views. Memory view objects allow Python code to access the internal data of objects that support the buffer protocol without copying. Dude, C is so much easier than this. I don't understand why you have all this stuff here. Array, dot array, I, whatever. Well, I can look this up later. Index. Right. Okay, set types. A set object is an unordered collection of distinct hashable objects. Common uses include membership testing, removing duplicates from a sequence, and computing mathematical operations such as intersection, union, differences, and symmetric difference. For other containers, see the built-in dict, list, and tuple classes in the collections module. Like other collections, set support in X and set, len set, and X for X in set. Being a non-ordered condition, sets do not record element position or order of insertion. Accordingly, sets do not support indexing, slicing, or other sequence-like behavior. There are currently two types of sets. Set types set and frozen set. The set type is mutable. The contents can be changed using methods like add and remove. Since it is mutable, it has no hash value and cannot be used as either as a dictionary key or an element of another set. The frozen set type is immutable and hashable. Its contents cannot be altered after it is created. It can therefore be used as a dictionary key or as an element of another set. Non-empty sets, not frozen sets, can be created by placing a comma-separated list of elements within braces, for example, Jack and Jerd, in addition to the set constructor. Return a new set or frozen object whose elements are taken from iterable. Okay. So kind of like a C++ set, I'm guessing. Dictionary. A mapping object maps hashable values to arbitrary objects. Mappings are mutable. Mappings are mutable objects. There is currently only one standard mapping type, the dictionary. Okay, so you got dictionaries, which in C++ is called a map, I guess. Then you got list and set and tuple. So you got dictionaries, so on. Okay, cool. Dictionary view objects. Hey, what's this? So an example of dictionary view usage. So dishes is equal to eggs : 2. Okay, so you just create the dictionary and it knows it's a dictionary somehow. Dishes: eggs 2, sausage 1, bacon 1, spam 500. Keys: dishes.keys. Values: dishes.values. For volume values, print them. Oh, you add to huh? Okay, so you print the total. Right, so it's 2 plus 1 plus 1 plus 500 is 504. Right. What was the reason for that? Because it's adding up the values. Yep. Keys and values are iterated over in the same order. View objects are dynamic and reflect dictionary changes. Delete dishes sausage. List keys. Then you got set operations here. Okay. context manager types. There's Python's with statement. Supports a runtime concept of a runtime context defined by the context manager. Enter the runtime context and return either this object or another object related to the runtime context. Exit the runtime context and return a Boolean flag indicating if any exception that occurred should be suppressed. Although otherwise all three arguments are non, returning of true value from this method will cause the with statement to suppress the exception and continue execution with the statement immediately following with the statement. Right. I didn't quite understand that section, but whatever. Moving on. Type annotation types, general, generic, alias, and union. Alright, I'm going to skip past all this. Let's just move on to... here we go, methods. The other built-in types. The interpreter supports several other kinds of objects. Most of these support only one or two operations. Modules. Wait, I was in the library? Hang on a second, I thought I was in the tutorial. Yikes, okay. That'll explain why I was getting bored to tears here. Range. Break and continue. The break statement breaks out of the innermost and closing for a while loops. Somehow ended up on a massive tangent here. Holy moly. Okay, so yeah, you could call break, and that will... It breaks out of the innermost and closing for or while loops. So here you call break, and that will get you out of this. Sure. Colon, colon, colon. Man, they force you to indent every time. Why though? The continue statement continues, yep. Else clauses on loops. In a for or while loop, the break statement may be paired with an else clause. If the loop finishes without executing the break, the else clause executes. In a for loop, the else clause is executed after the loop, etc., etc., etc. Just kind of the usual stuff. Pass statements. The pass statement does nothing, huh? It can be used when a statement is required tactically, but the program requires no action. While true, pass. Busy, wait for a keyboard interrupt, Control C. Yeah, I guess that can work in that way, sure. This is commonly used for creating minimal classes. Class, my empty class, colon, pass. Okay. Another pass can be used as a placeholder for a function or conditional body when you are working on new code, allowing you to keep thinking at a more abstract level. The pass is silently ignored. So you define init log pass. Speaking of which, is that how you make a function? Let's try this. So if I say def, let me try this. Print word 10 times, and then you say word. I just guessed. Yeah. I'm just doing a lot of guesswork as we go along. So if I say pass, that's it. It's defined. But that's not what I want to do. I want to say for n in range zero colon 10 dot doesn't like that. Why doesn't it like that? Any feedback from chat? What am I doing wrong here? 1, 2, 3, 4. Pass. No? Okay, what's the issue? IntelliSense will tell me, right? Parentheses was not closed. Oh, it's a colon. Range with comma. Thank you. Martini. I almost thought it said martini. I could go for a martini. And a range. Right. Print. Word. Wasn't there also a way to separate it? Yeah, probably. But for now, I'll just say print, comma. Yep, and then I say fudge knuckle. Right. Printf. You just run the debugger, and it says, whoop. Close enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it worked. Sweet. Okay. I think I got it. So that's how you do a function. You just say def. Cool. And then to do class. We'll get into that in a second. So we got for a while break, usual stuff, pass, match. A match statement takes an expression and compares its value to successive patterns, given it as one or more case blocks. Oh, okay, so that's like why am I blanking? Oh, yeah, that's like a C switch. So, So, by the way, can you just return something? For n in range, it doesn't even... How do you return something? Does that work? Does it know what n is? print M. Wait, is that legal? I don't even know. Let's just try it. Oh, well, it's okay. So it prints off the last one. But if I instead want N, which tells me how many times it happened, then I would say N, or I could say N++. Does that work? No. That's one way to do it. There's probably an easier way to type that. Let me say return N. Alright, try it again. F5. Yep, we got it this time. There it is, 10. Okay, but back to the match statements. Right, so if we say match status, again, it's like a C switch. So we say, you literally say case colon. Oh, you know what? Here's a question. Does it work like a C switch exactly? Because does it pass through? Here, you know what? Let's test that out. If I say print, val is equal to 500. My question is, I say, no. So I say match val, right? So I say case 100, print you are a ... new line. Do I need to do it like that? I get mixed up about whether or not new line is needed or not. So you are a duck. See, I see returns here. So if I don't return, the question is, does it pass through? Case 200, print moose, case 300, print aardvark, case 400, print strawberry. Let's change the value to 300. So what happens? F5. You are a aardvark. But it didn't print strawberry. Okay, what if I... Well, it doesn't do the control D trick? Okay. Let's say... And then I do the return. Huh? Why is it red? Return can be used only within a function... Oh. But I could break. But now it's red. Break can only be used within a loop. Oh, doggone it. Okay. So the reason it's returning here Okay, so yeah, break doesn't mean the same thing here as it does in C. That'd be why. Aardvark. Here. You are a sea lion. And then, just for good measure, whoop. Earth. Earth. There we go. So if I go, you are a sea lion. That works for me. All right. You can combine several literals in a single pattern using ors. Huh? So it can... Oh, dude. Okay, that's kind of cool. 200, 300, or... By the way, does it have to be in a certain order? Probably not. 99? No, order doesn't matter. But if I say 400 or 500... Now, can I do another 500 after that? Probably not, but let's see. Case 500. Print. Huh? Case 400. Whoop. Print. Whoop. What? So if it's 400, F5. And so the value is 400. It went to this case, but not the second one. Right? Okay. Who designed this language? Okay. Anyways, guess it does the first one that matches, and then that's it. And then you're out. Cool. All right, what's next? And then you got classes. Now we're in the fun stuff. Here we go. If you, let's see. If you're using classes to structure your data, you could use a class name followed by an argument list representing a constructor, but with the ability to capture attributes into variables. So I'm guessing this is the initializer, self, and X and Y. You really have to type self every time. You don't have to do that in C++. Why? Why? This is supposed to be easier than C? Like, really? Class... What a joke. Class... I don't know what class we want to make. Class thing doer. Yep. Colon, right? So you define an initializer? Init. I'm guessing that's an initializer. So we say self and one thing, comma, I don't know why. One thing, I don't know why. Here we go. Self dot one. Bro, the IntelliSense doesn't know. Oh. I gotta copy it down. Yeah. Anyway, then you define so wait a minute. If I'm defining a member here, well, let's say the thing is shu and the don't know why is laces. So then how do you define more members? Def just print stuff. No arguments needed. And then we say print self dot one thing, right? Print self dot, I don't know. Or does it not know what I'm talking about? Oh, expected a clone, of course. Huh? Do I need to eliminate that? Well, everything I do in Python is completely illegal. I'm going to plead innocent in the court of Python. But let's try it. Thing doer TD. Or is it TD is thing doer like that? Huh? Okay. Did that work? Maybe? And then I say TD dot just print stuff. Is that legal? Type error. Missing 2 required positional arguments. Huh? Well, hang on a second. Oh, do I need self as an argument? What? No. No. Why? Who thought this was a good idea? No. No, that still didn't work. Hang on a second. By the way, define functions. Let's scroll down here. Let's go to defining classes. Hang on a second. How to create instance of class Python. A is equal to person. John. What? Isn't that what I did? Because I just said thing TD is thing doer, right? Am I crazy? I press F5. It's still throwing an exception there. Missing 2 required positional arguments? What? Oh, wait. Is it because I created those arguments? I'll try it one more time. Oh, there we go. So it prints shoe and then prints laces. Okay, so the reason you had these two things. Okay, so you have self. You have self, and then you have the members, which we define as one thing, and I don't know why. That's it. They just kind of show up there. How do you end again? Do they have a destructor? Do Python classes have destructors? Do Python structures? In Python, a destructor is a special method defined using underscores del when an object is about to be destroyed, allowing for cleanup tasks for resources. So how does that work? Then we say def del. Print. Oh no, why are you killing me? Look at how dramatic that is. Okay, let's see if I could delete TD. Does that work? Let's try it. F5. Oh no, why are you killing me? Like that. Dude, that's awesome. Alright. So yeah, we do have destructors, I guess. Oh, because if I, for example, run a function, def thing doer do the thing with thing doer. That's it. And we just literally bump all that stuff up. So does it delete it when it's done with it? See, remember, this time, I'm not even going to do it explicitly. I'm just going to see if the program does it for me. And then we say, we just invoke it directly like that. And that's it. Does it do the thing? We hit F5. Oh, okay, so it does invoke the destructor. Yep. Righto. Okay. How many more tangents am I gonna go on today? Okay, we did if statements, we did else, match, which is switch. Now I have to remember that match is switch. Switch is match, etc. Case. What the hell is this? So in this case, you're checking for a point that has coordinates 0 and 0, which is the origin. And then here you could say, is there a point where x is 0 and y is equal to y? What the hell is that? Why does it say y? Why? Huh? What? Y is y? Y is y? Doesn't matter. We could revisit that later. Patterns can be arbitrarily nested. For example, if we have a short list of points with match args, we could match it like this. Match args, huh? We could match it like this. Match args is equal to x and y. In itself xy. Self.x is x. Self.y is y. No points. Match points. No points. The origin, single point. Something else. Case underscore. Case underscore. Okay. Moving on. Class color enum. So we got a number of meters here. Why? What? So this is legal somehow? Let's try something. From enum, import enum. Does it know what that is? So then we say class. I don't know. World coordinates. No, wait. How about just say animals? Okay. Bear is equal to bear. Lion is equal to lion. Aardvark. Okay. Is that it? It's giving me a thingy. Oh, colon. So what? Constant, bear, literal, bear. Okay. Print bear. Right? Does that work? No, I don't know what I'm doing. Hang on a second. You say animal.bear. That works. So did I need to install anything for that? F5. Wait. Print a dot value? Does that work? F5. Nope. It didn't like that. String object is not callable. Oh. That's it. I just go like that. Because it's just called value. F5. Bear. Right. Okay, so if you print if I print A versus the A dot value. So I don't understand. What is this class? Go to declaration. Go to definition. Oh, wait. No, go to declaration. Oh, here we go. Enum is a meta class. You got a name and a value. Name value. Okay. So if I say print a.name, there we go. Try it again. There you go. The name is bear, the value is bear. Uppercase and lowercase respectively. Cool. Bear, literal bear. All right, what else do we want to do today? Here you have a Fibonacci function. A and B is 0 and 1 respectively, while A is less than n, prints blah, 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 blah. So it prints off the keyword def that introduces a function definition. Must be followed by the function name parentheses list of full parameters. The statements that form the body of the function. Start the next line and must be indented. The first statement of the function body can be optionally be a string literal. The string literal is function docstring. Blah, 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 blah. The execution of a function introduces a new symbol table used for the local variables of the function. By the way, can I enforce that a certain function argument has a certain type? So if I say def print string x number of times. So then if I say string word, we'll just say word. If I say colon str, does that work? I think so. Then if I say x int, does it force it to be an integer? Maybe. For this is not C. For x in range of 0 colon x colon, right? Pass. Does that work? What did I do? Oh, the comma! My chat already corrected me on this one. All right. For x in range, we just say print word. Then we say, so if I do something that's not arf, so we want to say arf 5 times, right? Now, what if I do something that's not a string? For example, if I say 25.4. See, the IntelliSense doesn't give me trouble, but does it turn that into a string? Let's find out. Press F5. It converts 25.4 into a string and prints it. Okay, let's do something more obviously wrong. Beetlejuice. We say it 3 times. But wait, instead of 3, we will say, hang on a second. Maybe goof juice. All right, this should be illegal, right? What happens? Press F5. Oh, there we go. String object cannot be interpreted as an integer. Okay, so in this case, it finds a way to turn 25.4 to a string, but it doesn't know how to turn a string into an integer. Now, what if I do 3.114? What does it say? Does it just convert it into 3 and skip and hop away? Let's see. Nope, it doesn't like that either. It has to be an integer. Okay. Yep. All right. Where were we? Define functions, etc., 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 etc. Fib, print fib. It's simple to write a function that returns a list of the numbers of the Fibonacci sequence series instead of printing it. Return a list containing a Fibonacci series up to n. Okay. Result is an array, right? An array? Well, so you append a result A. By the way, this is my REPL. 0. What's the difference? What's the difference between the square brackets and the curly brackets? Because it looks like with the curly brackets, I could say bar colon 1 comma shoe colon 300, 200. See, it likes that. But what if I make it into square brackets? Oh, it's mad. It's mad. Right, so it looks like a... Hang on. What about foo, shu, glue? See, it likes that. So, yeah, so the square brackets just means it's an array. And then I guess this is a list? Must be some kind of a list. Or a map in this case. Right. Okay. Where was I? So you could append stuff. You create an array, it's called result. The return statement returns with a value from a function. Return without an expression argument returns none. I mean, can you force a return type? How do you enforce a return type? Python. How to enforce, how to set return type on function. In Python, you could set a return type using type hints in the function signature. Oh, the pointy thing. So if, for example, we say, yeah, I've seen, that reminds me of something I've seen. Might have been lambda functions for C++. But you go def return 3 list 100 items, please. And then we say, how do you say an array of things? Int, like that? Does that work? Yes. Index or slice position expression. How to set return type. How to set function return type to array of ints. By using type hints. Huh? Or I could say list ints. List of int. Why does it look like that? List int. Do they not use the word array? They call it a list. So then you say return output is like that. Then you say for a in range of 0 to 100, call in 100. Bro, I'm losing it. Then we say output.append a. That's it. Let me say print A. Let's try running it, see if it works. None? Uh-oh. Oh, I didn't return the output, that's why. Return output. That's... okay, so... it should at least tell you didn't return anything. Nope, doesn't care. F5. There you go. 0, 1, 2, 3, 99. Cool. I can make it 8 plus 1. If I do it again, there'll be 1 through 100. There you go. Cool. But if I say hash, if I instead return, this should be illegal. And I should be arrested. Right? Press F5. What? Huh? I specify the return type as a list of integers and it does this. Bro, I'm losing it. This is why you have so many, you're going to have a lot of runtime errors if you can't even enforce something like this. Okay. Type hints, you can use a array module from blah, 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 blah. Wait. Because I could do an assertion, right? Assert a dot type. How do you check a type on something? How do you assert that the function returns the correct type? Doggone it. To assert that a Python function returns the correct type, you could use a built-in assert statement within a test or directly in your code. Below are some approaches, including examples. Simple assertion right after calling your function to... Bro, do I need to assert it every time? Okay. My function... See, we did that. Return 1, 2, 3. Okay. What? Assert is instance a colon list of int. So then there's that. Try it again. F5. There we go.
But I have to assert it.
Why didn't it should have just given me trouble when I returned in the first place. That's what I'm annoyed about. Because I already got my type hint. List int. But I return a string. This should be illegal and I should be arrested. I wrote that there for a reason. Anyways. Argument 2 cannot be a parameterized generic. But, if I put my hash here, this should work. F5. Oh. Well. So why didn't that work? Okay, output is list of output is How do you even check the type? Python print out name of type. To find the name of a type in Python, you could use a type function along with the name attribute, for example, print. All right, so if I say so print and the variable's a dot name. Right, so what is the type? Huh? Whoop, oh, I goofed. Hang on a second. Let's try this again. F5 again. All right, where was I? Okay, I got an output. Oh. Okay, one more time. See, it just says list, right? So if I say assert is instance, and I just say list, I mean, it will accept my assertion that it's a list. Right, F5 again. So it passes the assertion. Hold on a second. Okay. Think. All right, how many more tangents am I going to go on today? Wait, how do I... Python. How to assert function returns correct type every time. Okay, how do I assert variable type is a list of ints. Oh. Assert is instance my list, listen all is instance I. What the heck? What? You're killing me. Let's try that. So we say A. Oops. Okay. Right. So if I hit F5, I mean, it passes the assertion, but if, for example, we say and I say return 1.2, 1.4, 3, 4, 3.14, because this is now a list of floats. So that should not pass the assert. Hit F5. There it is right there. The variable must be a list of integers. Because if I let's make sure that it confirms that it's a list, because it probably will, right? Print yay1, and then we do a yay2, hit F5. So it did the yay1 but not the yay2, right? But we should get both yays when we do the regular stuff. Yep, yay1, yay2, and there's your list. Okay. Moving on, more defining functions. It's also possible to define a function with variable number of arguments. Oh yeah, so that's like defaults. There are three forms which can be combined. Default arguments. The most useful form is to specify a default value for one or more arguments. This creates a function that can be called with fewer arguments than is defined to allow. For example, prompt retries, reminder, please try again. Yep. Can be called in several ways. That's the usual stuff where you got overloads and stuff. The default values are evaluated at the point of function definition in the defining scope, so that print arg. Right. Wait. That's a global value? Hold on.
Wait. What? So let's say, hear me out, chat. N is 4, right? So I define a function f, and then we say arg is n, but for some reason the function actually says print, and then we say we increment n for some reason. Can you say plus equals 1? I guess that works. And then you say, wait. Where was I going with this? I don't remember. But there's your function, right? It just increments it. For n in range 0, 10. You just say function, you call the function, that's it. Print. And then we print n. Let's see. Wait. What is it complaining about? Oh. So this might work. Cannot access local variable n word is not associated with the value. Huh? Wait. Can I say n is I don't understand. Can I say n is equal to n plus 1? But it's going to complain about local values, I guess. So okay, so I can't really access global values, right? Am I understanding this correctly? But it could access it as an argument. So I could say print. Here. I could say print n. Yeah. Oh, arg. F like that. So I hit F5. What happens? 4, 4, 4, 4, 4, 4, 4. Oh wait, what was it gonna do? I totally forgot why I did that. Oh wait. Was it because I wanted to increment it anyways? N plus equals 1? Does that work? What? 4, 4, 5. That looks a little goofy. 4, 4. Huh? What? Print n. Four, 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 5, 4, 6, 4, 7, 4, 8. What the hell happened here? What am I even looking at? N is equal to n plus 1. Let's try that again. No, I don't know what happened. I would think it would print 10 things. Oh. You guys. All right. So it looks like you got the function printing. Gosh. So now I know what happened. When you're printing here, you're printing a global value. When you're printing here, you're only printing a local value. But it's not getting the global value every time. It's only getting it the first time. Seems like a nice way to set yourself up for failure. I don't like this feature. Like, you should just do something like default. So set the default to like 100. Yeah. Yep. But that's really confusing. If you set a default argument, it only uses it the first time, but not any time thereafter. It creates a constant. It doesn't dynamically update it. I can't believe it. Boy, I don't like that feature. Okay, guys, my brain hurts. Let's cut off the feed. All right. Let's call it a day, guys. F's in the chat for me. Good night. God bless you all. Any last words from the chat before we sign off? good day.